Have you ever wondered how airplane engines are made? Welcome to iPick, where we delve into the fascinating world of aviation. Today, we're embarking on a journey to understand the marvel of engineering that is the airplane engine. Airplane engines, the heart of these colossal birds of steel, have a rich history that dates back to the early 20th century. It all began with the simple piston engines propelling the first aircrafts through the sky. Over time, the quest for speed and efficiency led to the invention of turbojets, and eventually, the high-bypass turbofans that we see on commercial aircraft today. These engines, with their intricate design and precise operation, have revolutionized the way we travel. They've bridged continents, connected cultures, and made our world a smaller place. It's hard to fathom that the sheer power that lifts a Boeing 747 off the ground, carrying hundreds of passengers across oceans, comes from a meticulously engineered piece of machinery. Each component of an airplane engine plays a crucial role, working in harmony to convert fuel into thrust. From the fan blades that draw air into the engine, to the combustion chamber where fuel is burned, to the turbine that harnesses the energy from the exhaust gases to drive the compressor and fan, every part is a testament to the genius of modern engineering. The manufacturing process of these engines is a feat in itself. It requires an incredible degree of precision, expert knowledge, and cutting-edge technology. Every single engine part is crafted, assembled, and tested to ensure optimal performance. This is a process that leaves no room for error. After all, a flaw in the engine could mean the difference between a safe flight and a catastrophic failure. So, why does all of this matter? Because understanding the science behind these mechanical giants helps us appreciate the complexity and beauty of aviation. It reminds us of the human ingenuity that has made it possible to defy gravity and soar above the clouds. Today, we dive into the intricate process of manufacturing these mechanical giants. To understand the manufacturing process, first, we need to know the key parts of an airplane engine. The beauty of an airplane engine lies in its complexity and the harmony of its parts working together. Let's take a moment to appreciate the key components that make up this marvel of engineering. First up, we have the fan. This is the most visible part of the engine, the large spinning blades you see when you peep out of the airplane window. The fan has a crucial role in propelling the aircraft. It pulls in a large volume of air, a majority of which bypasses the engine and is thrust out the back, providing around 80% of the engine's thrust. Next, we find the compressor. It's less visible, but equally vital. This part is a series of smaller fans that gradually compress the air drawn in by the fan to a high pressure. This compressed air is then directed into the combustion chamber, ready for the next stage of the process. The combustion chamber is where the magic really happens. Here, the compressed air mixes with fuel and ignites, creating a high-pressure, high-temperature gas. This explosion of energy is what gives the aircraft its power to soar through the skies. Last, but certainly not least, we have the turbine. Situated downstream of the combustion chamber, the turbine harnesses the energy from the high-pressure gas. It uses this energy to drive the compressor and the fan, completing the cycle that keeps the engine running. Each of these components plays a critical role in the operation of an airplane engine. They work in unison, each relying on the other to perform its function effectively. It's a symphony of engineering precision, a testament to the ingenuity and tenacity of human invention. Now that we know the key components, we can delve into how they come together. The process of manufacturing an airplane engine begins with the crafting of the fan blades. Our journey into the heart of an airplane engine commences with one of its most intricate components, the fan blades. These seemingly simple shapes are the result of meticulous design and precision manufacturing, ensuring they can withstand the extreme conditions they encounter during flight. The fan blades' journey begins with the selection of materials. These blades are often made from a blend of titanium and nickel alloys. This unique blend is chosen for its exceptional strength, lightweight properties, and resistance to heat and corrosion. Titanium's lightness reduces the engine's overall weight, while the nickel alloy's durability ensures the blades can withstand the tremendous forces they will face in operation. The molding process is a marvel of modern engineering. The alloy blend is first melted down and poured into a ceramic mold. This mold is precisely engineered to match the exact shape and dimensions of the final fan blade. Once the alloy cools and solidifies, the ceramic mold is broken away, revealing a rough blade ready for the next stage of crafting. Precision is paramount in this process. Each blade must be identical to its counterparts, down to the smallest detail. This is where the blades undergo a process of meticulous shaping and polishing, transforming them from rough castings into sleek, aerodynamic components. High-tech machinery and skilled engineers ensure that every inch of each blade is perfect, from the root to the tip. This precision is not just for aesthetic purposes. Even the slightest imperfection can affect the blade's performance, potentially leading to engine failure. Therefore, each blade is subjected to rigorous quality control checks, ensuring they meet the highest standards of perfection. The fan blades are more than just components of an engine. They are the first point of contact for the air that propels an aircraft forward, playing a crucial role in the engine's overall performance. Their design and manufacture are a testament to human ingenuity, blending art and science in equal measure. Once the fan blades are shaped and polished to perfection, we move to the next step. The compressor is where the air gets squeezed, and its assembly is a crucial step. Delving into the building process, the compressor assembly begins with the meticulous crafting of each component. The compressor is composed of numerous rotating and stationary blades, all of which require the utmost precision in their construction. These blades are composed of high-strength alloy materials, designed to withstand extreme temperatures and pressures. Each blade is carefully placed onto a disc, forming what is called a rotor. There are numerous stages of these rotors, each with their own set of blades. The blades on the front stages are larger as they deal with low-pressure air, while the blades get progressively smaller as the air pressure increases in the later stages. Stationary blades, also known as stators, are then installed between these rotating stages. Their role is crucial as they redirect the air onto the next set of rotating blades at the right angle, helping to maintain the high pressure. The assembly of these components is a delicate process. The blades must be meticulously aligned to ensure smooth airflow and prevent any imbalance that could lead to catastrophic results. The precision required in this stage of assembly is paramount, and it's achieved through a combination of skilled craftsmanship and advanced machinery. Once the blades are in place, the compressor is enclosed in a casing made from robust, heat-resistant materials to withstand the high temperatures produced during operation. This casing is more than just a container. It provides structural support and helps direct the airflow in the right direction. The assembly of the compressor is a testament to the marvels of modern engineering. It requires a blend of precision, strength, and attention to detail that few other manufacturing processes can match. Looking at the assembled compressor, it's hard to imagine the intricate process behind its creation. But each stage, each blade, and each component plays a vital role in harnessing the power of air to propel an aircraft through the skies. With the compressor ready, we are one step closer to a complete engine. The combustion chamber and turbine are the heart of an airplane engine. In the world of aviation, the combustion chamber and turbine play a crucial role in the operation of an airplane engine. This is where the magic happens, where the fuel-air mixture ignites and the resulting force is harnessed to propel the aircraft forward. The process of building these components begins with the selection of the right materials. The combustion chamber, where the high-pressure, high-temperature combustion of the fuel-air mixture takes place, is typically made of heat-resistant materials such as nickel-based alloys. These alloys are known for their ability to withstand the extreme temperatures and pressures found within the combustion chamber. The construction of the combustion chamber involves a process called superplastic forming. This process allows the nickel-based alloy to be formed into complex shapes that increase the efficiency of the combustion process. It involves heating the material to a temperature where it becomes pliable, then using air pressure to shape it into the desired form. Once cooled, the material retains its shape while regaining its strength and heat-resistant properties. Moving on to the turbine, it's essentially a complex windmill. It catches the high-speed gases exiting the combustion chamber and uses their force to spin a shaft. This spinning shaft then powers the compressor and fan, completing the cycle that allows the engine to produce thrust. The turbine blades are made from the same heat-resistant materials as the combustion chamber. They are crafted using a process called investment casting, where a wax model of the blade is made, covered in a ceramic material, and then heated until the wax melts away, leaving a ceramic mold. Molten metal is then poured into this mold to create the blade. These components are then meticulously inspected and tested. Any imperfection, no matter how minor, can lead to catastrophic failure, so the quality control process is incredibly rigorous. In essence, the The combustion chamber and turbine are where the raw power of an airplane engine is generated and harnessed. They are the heart of the engine, and without them, the airplane simply wouldn't fly. With these parts ready, it's time to bring everything together. The final assembly is where all the parts come together to form a functioning airplane engine. Now, we've arrived at the final assembly, the crescendo of the engine manufacturing process. This is where each meticulously crafted part, from the fan blades to the combustion chamber, is brought together to create the masterpiece that is an airplane engine. The assembly process begins by installing the fan at the front of the engine, followed by the compressor, combustion chamber, and turbine, all in sequence. These parts are interconnected, forming a single cohesive unit. Each piece is carefully fitted into its place like a mechanical jigsaw puzzle. But the assembly doesn't just rely on brute force. Precision is key. Every part must align perfectly, down to the smallest millimeter. After all, in the world of aviation, there's no room for error. Once the engine is fully assembled, it's time for the testing phase. This is where the engine proves its mettle. Rigorous tests are conducted to ensure the engine's safety, reliability, and efficiency. One of the crucial tests is the performance test. It checks the engine's power output, fuel consumption, and overall efficiency. The engine is made to run at full throttle, mimicking the conditions it would face in the air. Next comes the durability test. It's a test of endurance, pushing the engine to its limits. The engine runs for an extended period, simulating the wear and tear it would experience during a long-haul flight. Then, we have the safety tests. One such test is the blade-out test, where engineers intentionally cause a fan blade to fail, ensuring that the engine can withstand such a scenario without catastrophic damage. Each test is a hurdle, a gauntlet that the engine must pass. Every engine that passes these tests is a testament to the engineering marvel that it is. Once the engine passes all the tests, it's ready to take to the skies. And it's not just an engine that takes flight, but the countless hours of hard work, precision, and dedication that went into its creation. Let's recap the fascinating journey we've just taken through the process of manufacturing an airplane engine. We started our journey by delving into the intricate world of aviation, where we learned about the crucial role that engines play in powering our flights. We discovered that an airplane engine is not just a single unit, but a complex assembly of numerous parts, each with its own unique function. We then moved on to the crafting of the fan blades, the first component of the engine. These blades play a pivotal role in drawing in massive amounts of air, a vital ingredient for the combustion process. We saw how these blades are meticulously crafted, shaped, and finished to withstand incredible forces during flight. Our journey continued with the assembly of the compressor. This component is responsible for compressing the air drawn in by the fan blades, increasing its pressure and temperature. We found out that the compressor is a series of rotating and stationary blades, each carefully crafted and assembled to work in perfect harmony. Next, we ventured into the heart of the engine, the combustion chamber, and the turbine. The combustion chamber, where fuel is mixed with compressed air and ignited, is a high-temperature, high-pressure environment. The resulting hot and high-pressure gases then move to the turbine, where they are converted into the mechanical energy that powers the aircraft. Finally, we arrived at the final assembly and testing phase. Here, all the components we've learned about are brought together to form the complete engine. Rigorous testing ensures that the engine meets all safety and performance standards before it's ready to take to the skies. Understanding how airplane engines are made gives us a new appreciation for the marvel of flight. Join us next time on iPick as we continue to explore the intriguing world around us.